Good morning. Today I will be demonstrating how to remove and replace a broken duplex receptacle. First, I must test for the absence of voltage using a plug-in voltage tester. By plugging this tester into the receptacle, I will be able to determine if there is current flowing through the receptacle. As we can see, by the lack of illuminated lights, there is no current flowing through this receptacle, and it is safe for me to operate on. We must also ensure that power is turned off at the main disconnect switch. As you can see by the markings on this switch and its position, the power is indeed off. Next, I will use a flathead screwdriver to remove the receptacle faceplate. I will then use a Phillips head screwdriver to remove the 632 screws that connect the receptacle to the non-metallic box inside the wall. To allow easy access to the wires connected to the receptacle, I will pull the receptacle directly out of the wall. Once again, using the Phillips head screwdriver, I will loosen the terminals on either side of the receptacle by turning the screwdriver in a counterclockwise manner until there is enough space for me to remove each individual wire. Now that I have removed the broken receptacle, I will discard it and get a new duplex receptacle. As you can see by the markings on the front of this receptacle, it is marked TR. That stands for tamper resistant. In the last 3 years, there have been 3,000 infant injuries related to electrical accidents. By using tamper resistant devices, we attempt to minimize these injuries. I will now begin to reattach the conductors to the duplex receptacle, keeping in mind of the general rule of black on brass and white on silver, along with the bare copper wire on the green grounding screw. Using the Phillips head screwdriver, I will tighten these terminals in a clockwise manner until sufficiently tightened. Now, I will reinsert the duplex receptacle into the non-metallic box by folding the wires in a professional manner, not only as a courtesy to the next electrician, but to prevent any sort of accidents such as shorts or trips. 632 screws, like the ones I am working with right now, are somewhat of a standard in the electrical trade, being found not only in receptacles and switches, but also in fire alarm systems and in motors. Finally, using a flathead screwdriver, I will recover the receptacle using a metallic faceplate with another 632 screw. The final step is to use this plug-in voltage tester to ensure that I have actually wired this receptacle properly and that it will work. By plugging the tester into the receptacle and turning on power at the source, we can see by the two illuminated lights that this receptacle is fully functional. This concludes my job skills demonstration. Thank you.